day, everyone. Well, make sure that came out. Good day, everyone. This is Alan Schimmel, CEO, founder of Techstrong Group, and welcome to another Techstrong Learning Experience. We are thrilled to have you here today. This particular event today has garnered a much bigger than average sign up, and so I can only imagine it's because it's a topic that's attractive and relevant to you all. So thank you for being here. If you are listening to this live and you've logged on with us, thank you so much. If you're listening to this on demand, you know what? You're not missing anything by not having it live, other than maybe asking a question or two in chat. But thank you very much, whether you're live or on demand, for taking time out of your day to spend some time with us. Hopefully it'll be worth your while in learning. Before we start, I want to thank the good folks over at NGINX, an F5 company or an F5, for sponsoring and presenting today's session. Today's session, in case you don't know, is Shifting Left to DevSecOps with NGINX. And of course, this is a pretty important topic to us here at DevOps.com and Security Boulevard, as well as Cloud Native now. You know, 3 of our sites. The whole shift left, the whole topic of DevSecOps is something we cover quite a bit. Our presenter today is Fabrizio Fiorucci. Fabrizio is EMEA Solutions Architect with F5. And I want to welcome Fabrizio for joining us. Fabrizio, thank you very much for joining.
Thank you.
Yes.
Thank you, Alan.
You're welcome and presenting. Just a couple of ground rules we'll lay out here. The public chat is open. I see a bunch of people have already logged in to tell us where they're from, and that's always much appreciated. I always get a kick out of seeing literally a worldwide audience for these things, and we certainly have one today. A lot of folks from the West Coast, Seattle, Washington, and New Mexico, all the way into Eastern Europe and to Asia and South Africa and India. And so thank you all for coming in. If you have a question, we don't have a formal QA set up at the end today, but if you have questions, you can ask that in the public chat. Fabrizio, if he has a chance, will try to answer. I may try to answer. We have a record of it if we want to answer or after the fact via email or what have you. So we will do our best. So you can use the chat for that. Excuse me. But really, this is a pretty comprehensive presentation Fabrizio has prepared. And without wasting more time, let's turn it over to him. Fabrizio, take it away.
Thank you, Alan. So hello, everyone, and welcome to this webinar that is named Shifting Left to DevSecOps with NGINX. And as Alan said, my name is Fabrizio Fiorucci. I'm an EMEA Solution Architect working at F5. And today we will discuss what we have to consider when looking to implement a shift-left approach to app security and the potential for significant protection from a breach, like the ability to easily scale security while we maintain high performance and increase business benefits when moving towards a DevSecOps culture. So our agenda today, we will cover the topics as follows. How is business digital transformation shifting the security paradigm? Then shift left, what is it and why we have to adopt a DevSecOps culture? DevSecOps, challenges, benefits, and a path forward. How NGINX Protect can help organizations to shift left. Some best practices on what to consider when moving towards a shift left culture on the road to DevSecOps. So we can start. So business digital transformation continues to ramp all along 2023. This information shown here is from the annual F5 2023 State of Application Strategy Report, where approximately 1,500 IT decision makers from different organizations around the world responded to this survey. Within the survey, we have found that digital transformation for organizations continues to accelerate globally. While teams are dispersed geographically and application components are separated into microservices, on various cloud infrastructure, the network has become a very attractive attack surface. Digital transformation efforts typically proceed through three phases. Phase number one is task or process automation. Phase number two is digital expansion, and then AI-assisted business. We have found that more than 8 in 10 organizations are presently working on modernization and digital expansion. All of these efforts are more than twice as common as before the COVID-19 pandemic, when only slightly more than a third of organizations undertook them. The pandemic, in fact, jolted digital transformation forward by years, and the current modernization activities include the development of modern applications, the addition of modern components to traditional apps that provide core business functions to change how the apps are accessed and experienced. Some examples include mobile apps that interface with the fundamental logic that is powering industry, such as banking and insurance, or order entry and tracking integrations for the control or manufacturing equipment. The information shown here in this slide is also from the recent F5 2023 State of Application Strategy report, and security challenges continue, but several solutions exist. In this hybrid and distributed application landscape, it is not surprising that nearly 9 out of every 10 respondents who operate in multiple clouds, they continue to cite challenges with security, performance, and cost. The top challenge in 2023 was the complexity of tools and APIs that results from the lack of standardization or interoperability of the various tools that are used to deploy different models of security. Applying a consistent security policy is the next largest challenge for the second year in a row, with performance optimization not far behind. All of these challenges are no doubt why organizations in the Americas and in Europe, Middle East, and Africa call multi-cloud networking the most exciting trend over the next few years, though other trends ranked slightly higher in other regions globally. Other solutions that are available now for connecting, protecting, and managing complex infrastructures include more automation, ecosystem approaches, and partners who can help simplify by consolidating tools and policy enforcement for applications when they are distributed across different environments. Declarative deployment policies that deliver a consistent level of security can extend protection globally while helping to remove friction between functional silos. And since hybrid IT is not going away at any time, the same solution that is multi-cloud management will increasingly prove more and more helpful to most organizations. In the slides, we can see some additional app vulnerabilities and attack vectors that bad actors look to take advantage of. Modern applications have more frequent code commits, and this potentially introduces new security threats, data and personal identifiable information exposure, and this can jeopardize the business. For best practices, we must consider that applications are always in the crosshairs of attackers. Every single application needs to have protection against software vulnerabilities and common attacks. Let's keep in mind that it's not just the application itself that could have vulnerabilities. It can be any part of the application stack, from the operating system to application servers, Kubernetes environments, and every single library that is being used. Many applications are vulnerable to the same attacks that we have seen for many, many years. And this includes attacks that you probably might have heard of, attacks like injection, cross-site scripting, and so forth. One might think that we could have solved these problems over the years, but they are difficult to solve, and this is why they continue to rank so high on the application security list that we can find in the OWASP top 10. So, going forward to shift left, what is it? When we refer to the topic of shift left, what we are describing is bringing security in early to the software development lifecycle, also known as SDLC. Shifting security left and making sure it is included in every stage of the continuous integration and continuous deployment pipeline, making security everyone's responsibility, as this image shows. This is a move to a cultural change within an organization, which is called DevSecOps. And in DevSecOps, security is added into the development and operation, or DevOps process, aiming to integrate security into the rapid release cycles that are typical of modern software app development and delivery. The ultimate goal of DevSecOps is to have development, security, and operations team working together to enable agility and to create business value. And this is achieved through fast delivery of secure software using a process of continuous security. Shifting security left entails building and using security tools and controls throughout the pipeline for applications, containers, microservices, APIs, and more. And all of this relies on automation in order to maintain consistency and keep up with the rapid pace of development. By incorporating security as code as an approach, like infrastructure as code, organizations can use declarative policies to maintain the desired security state, getting out of the way of innovation. Security automation and AI reduced breach cost by roughly 33%. In the 2023 cost of a data breach report published by IBM Security, they studied 553 real breaches across 16 countries and regions and 17 different industries. This report offers IT, risk management, and security leaders useful insights into dozens of factors that can increase or help mitigate the rising cost of data breaches. In the course of nearly 3,500 interviews, they asked questions to understand what organizational activities for the discovery of an immediate response to a data breach. In this extensive report that consists of 78 pages, the number one takeaway was that organizations the most significant cost savings had high level of security automation and AI. Organizations with no security automation had a breach cost of more than $5.3 million on average in 2023, and this is versus $3.6 million on average at organizations that fully deploy security automation. That's a massive 33% of difference, which is roughly $1.76 million.
Well, this is incredibly important stuff, and I'm glad Fabrizio is talking a little bit about AI and automation, because so much of that is becoming more and more possible today. But a lot of organizations, they really haven't wrapped, until you've actually been the victim of a breach, it's hard to wrap your head around the true cost of these breaches, right? Because it's the old downtime. How much does downtime cost you? So it's important, and I think once you realize it, you start recognizing how important it truly is to use security automation and AI. And I would mention, when we're talking about AI here, it's not necessarily the Chat GPT AI, but it's more of course, the machine learning AI that we've had for some time.
So right now, let's take a look at some of the significant breaches that occurred in 2023 and how shifting left and automating security is becoming table stakes for all organizations. First, one of the most impactful and most widely known hacks in 2023 wasn't a single incident, but it was a series of devastating breaches beginning in May, caused by mass exploitation of a vulnerability in the popular file transfer software known as MOVEit. This vulnerability allowed the hackers to steal data from a laundry list of international government entities and businesses like Shell, British Airways, and the United States Department of Energy. By the time a fix was applied, the data extortion group had already gone on a disastrous joyride, exploiting the vulnerability against as many victims as possible. The second attack was to the identity management platform Okta, and they disclosed a breach of its customer support system in October 2023. In November, they assessed that all of their customer support users had their data stolen in the breach. The attacker ran an automated query of a database that contained name and email addresses of all Okta customer support system users and some employees. As with a number of other incidents in 2023, part of the significance of this specific Okta incident comes from the fact that the company plays a critical role in providing security services for other companies. And the third breach shown here occurred in June 2023 when Microsoft said that the hacking group had stolen an immensely sensitive cryptographic key from the company's system that allowed the attackers to access cloud-based Outlook email systems for 25 organizations, including multiple US government agencies. The incident was a reminder that hackers conduct massive quantities of espionage operations each year and are often lurking undetected in networks, just waiting for the right moment to capitalize on any flaw or mistake or vulnerability. Extensive security AI and automation reduced the time to identify and contain a breach by more than 100 days. In the same Cost of a Data Breach report from IBM Security, organizations with fully deployed security automation were able to detect and contain a breach much more quickly than organizations with no security automation deployed at all. For those organizations with fully deployed security automation, it took an average of 167 days to identify the breach and 47 days to contain the breach, for a total life cycle of 214 days overall. For those organizations that had no security automation deployed, it took an average of 237 days just to identify the breach and an additional 85 days to contain, for a total life cycle of 322 days, which is slightly less than a year. The difference in breach life cycle of 108 days represents a difference of 34%, so it's really significant. Why are organizations moving to automating security very early in the software development lifecycle and thus adopting a DevSecOps culture? So the current wave of digital transformation has made every business a software-centric company in essence. Therefore, adoption and data security have a critical role in avoiding breaches. Additionally, data protection laws like GDPR, CCPA, and others increased pressure on companies in order for them to protect their digital assets, which is something impossible to guarantee with occasional vulnerability assessments. DevSecOps can also help them reduce costs while improving software delivery quality. To fix vulnerabilities before an app is placed into production costs 100 times less. The price tag also diminishes when a team steadily improves security controls rather than responding to incidents that can impact the business. However, when moving to a DevSecOps culture, organizations need to consider moving beyond the SDLC model to incorporate security into the overall company culture. And this makes security everybody's responsibility in order to drive a successful adoption and the proper business goals. Adopting DevSecOps practices has several clear advantages, but that doesn't mean it's easy at every step. From the day-to-day mechanics of securing distributed applications to the heavy lift of cultural change, bringing this DevSecOps approach into an organization presents several challenges. Unless the organization is already moving in lockstep, it can be challenging to understand what dependencies each team incorporates in their builds, what tools are important and which are abandoned, and how code flows from individual developers' laptops to the CI/CD pipeline. To shift security left means baking security into every aspect of the security software supply chain. When looking at SecOps, the security team must shift from a gating mindset where they stop everything, troubleshoot, review a problem, to establishing guardrails that help development continue with fewer problems. By building new policies, tools, and recommendations, the security team can help developers keep moving safely. With automation and self-service, security can help developers help themselves. Security engineers can use their extensive knowledge about what attacks are possible to help developers building security much more effectively. When looking at DevOps and app dev, developers must become more aware of security risk at every stage of development. Selecting packages and libraries as dependencies, planning application architecture, deploying environments, writing functions, running tests are all processes with security implications and needs. Developers must take their own responsibility for assessing and managing these risks and for continuing to accumulate knowledge that doesn't make their work more secure in general. So how can these teams come together? So as more and more companies recognize the need to bring security into the core of development, DevSecOps has proven to be a natural evolution of DevOps. Just as DevOps naturally grew from Agile, developers, operations, and security teams work together as one team on threat modeling, sharing their knowledge in order to anticipate and close potential weaknesses in both the product and the processes involved in its development. This is a major cultural shift and makes security everyone's responsibility, reducing friction among the various teams. So the cultural shift that DevSecOps represents is very significant. Security and DevOps teams work with a common purpose to bring high-quality products to the market quickly and securely. Developers no longer feel stymied at every turn by security procedures that stop their workflow. Security teams no longer find themselves fixing the same problems over and over. This makes it possible for the overall organization to maintain a strong security posture, catching and preventing vulnerabilities, misconfigurations, and violations of compliance or policy as they occur. So the CI/CD pipeline is built for speed, not for security. The number of developers outnumber those of security 100 to 1. So this imbalance is where we are today. These numbers are not getting better anytime soon. We need to reconsider how we do security. So implementing security as we have traditionally doesn't fit into the need for agility and the new norm for modern applications. Shifting security left in the CI/CD pipeline enables game-changing innovation for speed and high-quality experiences. Shifting security left helps security keep up with DevOps software development model while managing emerging vulnerabilities and risks, while at the same time helping organizations reduce costs. So what is the big reason for many organizations slow time to patch? It's again because developers outnumber security 100 to 1. Moving to security as code is a process for many companies that have legacy apps with legacy security solutions and that have been in business for years versus a startup or any kind of new business that is using a new architecture and probably building in the cloud. Security teams can now enable security as code so that it integrates security inside the development process right at the beginning, where it's more cost efficient to fix any issues. Security needs to be included as part of the test plan with all the other testing to avoid running into issues in runtime or even worse in production. Having security as code enables the developers to consume security policies as code that is managed and maintained by the security team, delivering services faster and making them fully production ready. So shifting security left, once again, means embedding security by design throughout the SDLC. Shifting security left involves strong security.
So while we're waiting for Fabrizio to come back, I mean, so this is a pretty good, this current slide we're seeing right here, this is a pretty good representation of the DevSecOps tool set that are available within CI/CD. I mean, looking at it, though, I'll tell you some of these are a little dated. Electric Cloud hasn't been around a while. They were acquired by CloudBees, which is Jenkins, and CloudBees has, of course, a non-Jenkins CI/CD product platform as well now. A lot of people are not using necessarily Chef or Puppet or SaltStack for deployment. We're seeing, because of the rise of cloud native, you see open source tools like Argo. And Terraform is still there, of course. Harness is another deployment, CI/CD deployment tool. So some of these are opening up and being updated. And then I will tell you, in terms of monitor, a lot of us call it observability now. And Grafana and Datadog, New Relic, Prometheus. I mean, that's another area that the open source market has really made a big change to, especially with the open source tool OpenTelemetry. OpenTelemetry is, I think, the second largest open source project behind Kubernetes itself in the Cloud Native Computing Foundation. And there's a whole flock of folks, of commercial vendors using that for observability and monitoring. But what's interesting is we're also now using observability on the green side of the house there, on the dev side of the house, where we're doing monitoring and observability, especially using ML and AI. We're applying that pre-deployment. There's a question here about, based on my experience, how long it takes to implement this process. To really look, moving from a waterfall to DevOps and then implementing DevSecOps, there's a lot of variables there. Generally, you don't just in one fell swoop do it organization-wide. You do it in small teams and small places and kind of cut your teeth on it and learn and then expand it out further. But my experience shows me that it oftentimes for a decent size organization, it could take a few years to totally migrate to DevOps and DevSecOps like this. Where does Azure DevOps fit into this? I've never seen anyone mentioning that mature tool. Is the industry still hating Microsoft? No, I don't think the industry hates Microsoft at all, and I think Azure is a great cloud platform. Azure DevOps is Microsoft's sort of, let's call it, end-to-end DevOps platform. So the big end-to-end DevOps platforms, GitLab, GitHub, which is Microsoft, right? And then how does GitHub fit into Azure DevOps? CloudBees is another platform. JFrog has a full platform. I think Fabrizio might be back here, but Azure DevOps is definitely what I would call an end-to-end Microsoft platform, and it's very popular. Is it better than any of the other platforms or worse than? No, I think it all depends on what your specific requirements are. Fabrizio, can you hear us?
Thank you, Alan. Okay, so we were discussing about why are WAFs essential for app security. Web application security is complex, it's difficult, it's very difficult. WAF is the most cost-efficient way to address web app security, not to mention time-consuming and costly. Developing and maintaining comprehensive web security controls can consume a large percentage of the limited budget that you have for developing the actual application features that users will need to get their useful work done. We have already talked about how a majority of organizations are undertaking technology and digital transformation, and how apps are critical. Okay, so based NGINX Protect WAF and DOS, it's a WAF solution based on F5 Advanced WAF Engine technology, which is used across enterprises. NGINX Protect is a modern app software security solution that works seamlessly in DevOps environment as a robust WAF or app-level DOS defense that helps you secure your application and API across hybrid environments. Both security solutions are lightweight, high performance, and platform agnostic. And these are built around three priorities: strong app and API security, which is designed to protect and provide security control for the application to prevent downtime and breaches. Then second, high performance. That means low latency app security for applications that need to be protected. And this is designed for modern distributed applications from on-prem to the cloud. And third, simple integration into the CI/CD toolchain, platform agnostic, that enables security and dev teams to go to market faster at a smaller cost. NGINX Protect WAF and DOS accelerate the shift left movement, wherein security best practices such as implementing a WAF and DOS solution are introduced earlier in the development lifecycle of every app and API, during software development, during testing, and of course, during full production. You are able then to detect a lot more issues earlier, and engineers can then fix the issue before deploying the apps and API in production, and this saves a lot of heartache, time, and money. So across any organization, NGINX Protect WAF and DOS provides all the needed flexibility to support security from day one. These tools can be fully embedded into the overall infrastructure and application design, which is at the heart of the shift-left paradigm. One key factor of the overall solution is its being agnostic to the underlying layers. Security is fully decoupled from the on-prem, on-cloud, and hybrid kind of implementation, and the end user and all ops groups can fully focus on security regardless of where and how the actual building blocks will be deployed. Our customers can deploy NGINX Protect WAF and DOS as embedded security solutions for easy integration, high performance, low latency, and low compute with NGINX Plus in several different ways. For instance, at the ingress controller stage for Kubernetes environments, embedded on NGINX Plus, used as an API gateway, or as a per service and per pod proxy. Each one of these deployment options covers different scenarios and fulfills specific needs in terms of north-south or east-west based security, with the full ability to have mix and match kind of deployments that impose virtually no restriction on how security can be enforced, and this always guarantees full control, auditing, and traceability. WAFs provide critical security for all our applications and can be configured with knowledge of the application endpoints, APIs, and data. And this makes it easier to detect anomalies while leaving legitimate traffic alone. WAFs can also be aware of the users and devices using the app and which privileges they require. And this makes it possible to automate policies such as providing the lowest privilege, which is necessary to each client. In this way, a WAF makes it possible to shift security farther left, both efficiently and precisely, providing protection tailored to the application being developed and deployed. NGINX Protect WAF enables your organization to easily shift left by providing a robust level of security that goes way beyond basic signatures using trusted and proven F5 advanced WAF security technology. Securing apps anywhere is what NGINX Plus does when it's deployed, on-prem, on Kubernetes, and everything in between. And last but not least, NGINX Protect WAF shifts security closer to the application. And a security, in some sense, is baked in, it's not bolted on top. NGINX Protect WAF simplifies security provisioning as well and abstracts complexity using a tight integration with the NGINX Instance Manager and the NGINX control plane. Since applications and services rely so heavily on distributed infrastructure, the network itself has become a critical attack point. The application layer, in particular, layer 7, is very attractive to attackers because the complex communication among interconnected services and systems make it difficult to secure. Denial of service attacks can be hard to detect. Attackers can use encryption or network address translation to disguise the origin of their attacks, and this makes it more difficult to detect or filter malicious traffic. Because payloads are encrypted, it is difficult to differentiate attacks from legitimate traffic except at the endpoints. Attacks on layer 7 can be damaging with a lower volume of requests than a DOS attack on layers 3 and layer 4, meaning that rate limiting alone will not mitigate such attacks. Security tools must be able to recognize the difference between legitimate traffic and attacks reliably enough to know quickly when an attack has started and in order to mitigate that. NGINX Protect DOS, denial of service, seamlessly integrates with NGINX Plus and secures apps from layer 7 DOS attacks using automated user and site behavior analysis to secure apps and improve policies. A no-touch configuration model is leveraged to simplify DOS security for modern applications. So we can shift left and automate security as code within the CI/CD pipeline, and a logical place to start a review of DevOps tools is with code repositories. As those repositories, they are storing the code that makes up all of the applications deployed. Increasingly, they also store the configurations those applications require. Most organizations and developers use some sort of repository to store source code. At the very minimum, code repositories are a central place where teams can share and work on a common code base. The repositories also provide version control. Most code in applications come from a pre-existing library, modules, components, and artifacts. GitHub is a no-code source code management version control system, which is designed for projects both large and small. Where NGINX solutions come into play is that we help our customers move security controls to the left. We have an API-centric approach for our solution that enables both infrastructure and security policy controls to essentially be provided as code in the form of a declarative API. WEF security policies can be applied to existing WEF instances using the same automation processes. Security policies can be defined as simple JSON files, and just like application source code, such files can reside in a repository like GitHub. This enables the SecOps team to own and maintain common security controls that can be integrated into the app development pipeline, just like any other piece of code. This integration enables dev teams to stay agile and to accelerate innovation. To summarize it all, NGINX Protect makes it easy for your organization to shift security left by providing a modern app security solution that works seamlessly in DevOps environment as a robust web application firewall or as an app-level DOS defense that helps you deliver secure apps from code to customer. NGINX Protect is built around these three priorities: app-centric security designed to protect and provide granular security controls for all applications to prevent downtime and breaches, then a lightweight, high-performance, and platform-agnostic security solution across hybrid environments, and a CI/CD friendliness that enables security and developer teams to move towards a DevSecOps culture and drive innovation and go to market at a reduced cost. So now some best practices. The following are best practices to consider when moving towards a shift left culture on the road to DevSecOps. First of all, security must become everyone's responsibility. Security then must go beyond the CI/CD pipeline, and it must be part of the overall organizational culture. Then selecting cloud-agnostic tools can help avoiding vendor lock-in, especially when it comes to security. Then all teams must understand how application security policies are created and what is practical. Shifting left only works when developers understand security well. Not only do the developers need a good working knowledge of security development practices, they need enough education to understand the issues they are tasked with fixing. The key to solving these problems is to create a culture of collaboration that supports rapid and continuous iteration with a security focus. That means many teams, once siloed, learning to work together: development, IT operations, and security. Rather than a continual interruption, security must become a practice which is incorporated into every single aspect of work throughout the software development pipeline. Security teams must provide guardrails rather than gates, becoming continuous just like the development and operation parts of the pipeline. Beyond the change in attitude, DevSecOps provides tangible benefits, and by catching problems earlier, organizations deliver better, more secure products and services to their customers. Then the end user experience is way better when there are fewer urgent patches or unexpected breaches. So DevSecOps find these vulnerabilities much earlier and fixes them before they are deployed in production. This results in less downtime for customers and is much more cost-effective for the organization as a whole. So as we close our presentation today, I would like to invite you to test drive NGINX Protect Web for yourself with a 30-day free trial that can be found on the website at www.nginx.com. And you can also read more about shifting left for application security in a recent O'Reilly report, and how you can shift left to DevSecOps culture with NGINX Protect Web and DOS using the links that are shown on this final slide. So I wanted to thank you all for attending the webinar today on shifting left to DevSecOps with F5 NGINX. And this now concludes my part of the presentation. If you have any other question, don't hesitate to reach out to us via our website at nginx.com. And thank you.
Fabrizio, thank you. And I'm so sorry you had these problems with networks today.
We made it.
But we made it through, exactly. And thank you for your time and efforts. And it was an excellent presentation. I don't know if you're looking at the chat, but a lot of people thought that it was very, very useful and helpful. Thank you to F5, the NGINX team, for presenting today. I just want to quickly mention also under handouts, actually Cody put it in chat, is a survey we ask you to fill out to help make sure we're hitting the mark here to our audience in terms of topics you like to hear about or what you would like to hear about, you know, and absent network issues, I think this was great. Again, Fabrizio, F5, on behalf of Techstrong, thank you all for attending, and we hope to see you again soon at another Techstrong Learning event. Bye-bye, everyone.
Thank you, everyone.